Okay, so welcome to all of you. So last time we have seen the method of Langrages multipliers. We have explained the method in detail. We have solved 2 or 3 problems on it. Now we will continue that. So with the help of Langrages multipliers, find the maximum and minimum value of the function. Your function is what? E raised to xy, and the condition is given that x cube plus y cube is equal to 6. That means you have to maximize or minimize this function when subject to this condition. Okay, solution given that f of xy is equal to e raised to xy, g of xy is equal to x cube plus y cube is equal to 16. Okay, so now what we'll do, fx is equal to lambda times gx implies that. So e raised to derivative of e raised to xy is e raised to xy into derivative of xy partially with respect to x. So this is y. This is lambda into, so the partial derivative of g of x, g of xy with respect to x is 3x square. Okay. Now fy is equal to lambda g of gy. So this is what e raised to xy into x is equal to lambda into 3y square. Okay, so we call this as 1, we call this as 2, and we call this as x cube plus y cube equal to 16. This is 3. With the help of 1, 2, 3, we have to find the value of lambda, x and y. Okay, so what we will do? So x into 1 implies that. So xy, e raised to xy is equal to, so 3x cube lambda. Okay, so instead of this, what we'll do, we'll multiply by x to 1 and we'll multiply y to equation 2 and we'll take the addition of this one. Okay, so what 1 into x plus 2 into y gives, so we'll take the addition of this one. This is what xy e raised to xy. We'll take the addition of this. We have to multiply by y here. E raised to xy is equal to, so here what, lambda is common now, so this is what 3x cube plus 3y cube, 3x cube plus 3y cube. So this is twice xy, e raised to xy is equal to, so what here, lambda into 3 lambda, x cube plus y cube is what, 16. So 16, 48. So this is what, 48 lambda. Okay, so lambda is equal to, so this is what, 48. So lambda is equal to twice xy, so this is twice xy, 24. Okay, so xy upon 24 e raised to xy. So from this we did not get this. Okay, so what we'll do now here, so if you put lambda is equal to, we'll put lambda is equal to xy. Okay, so 1 implies to get the value of lambda, we'll put the value of lambda in 1. So this is what, e raised to xy into y, lambda is what, xy upon 24 e raised to xy into 3x square. Okay, now here what, e raised to xy get cancelled. So what we get then, e raised to xy get cancelled. So this is what, y. So this is what, e raised to xy get cancelled. So this is 3 also get cancelled. So this is 8 now. X cube upon 8, x cube y upon 8. Okay, so that means what here, so what does this imply? Y is equal to 0 or x is equal to 2 now, right? So because what here, you can shift this 8 to this side, and if you take the common, so that means what, y is equal to 0. That means you cannot cancel y actually. So y is equal to 0 or x is equal to 2. Okay, so what will put y is equal to 0 in, so if y is equal to 0, okay, so y is equal to 0 implies that So we find the value is 2 now. Okay, y is equal to 0 we put here. So this is what x cube is equal to 16. X cube is equal to 16. X cube is equal to 16. So x cube is equal to 16. So x is equal to, so instead of this, the problem becomes complicated. Okay, so x is equal to 16 to the power 1 by 3. Okay, so if x is equal to 2, if x is equal to implies, so x is equal to 2. So 2 cube is what? 8. So y cube is 8. Y cube is 8. So y is equal to 2. So we get 2 points. Okay, so 0. So therefore 0 y 0, that means what? 16 to the power 1 by 3, 0, and 2 are critical points. Okay, so we'll find maximum and minimum value. So directly we'll find the value of f of x y. So f of 2 is e raised to 4, and f of 16 to the power 1 by 3, 0, is what? Then e raised to 1 now. So e raised to 0. So this is 1. So you know that the value of e is the point and something, right? That means e to the power 4 is greater than this, right? So therefore f of 2 is so you want what? Minimum value. Okay, so 1 is minimum. So minimum is 1 and maximum e raised to 4. Okay, so we are through. Next, use Lagrange's multiplier to find maximum minimum values of the function here. No need to apply the second derivative now here. Okay, so of the function f of xy is equal to x square plus y square subject to constraint xy is equal to 1. This is your g of xy. Okay, solution. Given that f of xy is equal to x square plus y square, and g of xy is what? Xy is equal to 1. G of xy is equal to k. Okay, so fx lambda gx implies that. So what is the derivative? Twice x. So this is lambda into y. We call this as 1. Okay, now fy is equal to lambda gy. So this is twice y. Lambda into x, we call this as 2. Okay, so now we want to find the value of this one. So what I do? I multiply by x here and I multiply by y here. Okay, so x into 1 plus y into 2 gives what we get here. So I take the addition of the LHS. So y multiply by x, right, and I am multiplying by y here. So twice x square plus twice y square into this is xy, and this is what you are multiplying. This is what? Twice lambda xy. This will what? Twice lambda xy, because this is the xy and this is the xy also, right? So both the sides are same to this. Okay, so twice x square plus y square, this is a function. Okay, this is a function. You do not get anything now. Okay, you did not get anything because you don't have the value of x square plus y square. Okay, but you can find the value of lambda it becomes very complicated. Okay, so you can put the value of lambda is equal to x square plus y square upon xy. So what we'll do? So we'll multiply by x. We'll multiply by x. So lambda x we get. So that means what? Twice x square. Okay. So x into 1. This implies what? Twice x square is equal to lambda xy. Y into 2. What does this imply? So twice y square is equal to lambda xy. That means this lambda xy both are same. That means your twice x square is same as twice x1. So twice x square is equal to twice x2. So this implies that x square is equal to y square. This implies that x is equal to plus or minus y. Okay. So now with the help of this relation, so I have to write here what? Xy is equal to 1. This is 3 now. Okay. So if x is equal to y, then if x is equal to 1, then what? Xy is equal to 1. So that means what? Then y square is equal to 1. Because what? Your x is same as y now. Y square is equal to 1. This implies that y is equal to plus or minus 1. Right? So that means what? X is equal to y here. So y is equal to plus or minus 1 implies that x is equal to plus or minus 1. Okay? So if x is equal to minus y, then minus y square is equal to 1, because we are putting this x equal to 1. So y square is equal to minus 1. This is what? Y square is equal to minus 1. This is not possible. This is not possible. This is not possible. That means what? We have only this point. What? Therefore, plus or minus 1. These are the 4 points actually. Plus or minus 1, plus or minus 1. Because what? If we take plus 1, plus 1, plus 1, plus 1, minus 1, minus 1, plus 1, minus 1, minus 1. That means these are the 4 points are critical points. Critical points. So these are the 4 critical points. So what we have to find the maximum and minimum values, right? So no need to apply the second derivative test. We will find the value of function at all the 4 points, and we will see which one is maximum and which one is minimum, and then we can write the maximum value of the function and the minimum value of the function. Okay. So here what? F of xy is what? Plus or minus 1, right? Plus or minus 1, this x square y square. So that means if you take plus or minus 1, doesn't matter this what, because then square is 1, right? So that means directly you can find the value of this one, what? Plus or minus 1, plus or minus 1. This is what? 1 plus 1 is 2, right? So we get only this value. So we cannot imagine that whether this function is maximum or minimum. So we get only 1 point actually. Okay, so this is the extreme value. So extreme value of f is 2. Okay, so just write extreme value of f is 2. Okay. Next, we take the next problem. Use Lagrange's. So command is given to you here. What? Use Lagrange's multipliers. Right? So you have to apply this method. You cannot apply the last method. So find maximum minimum value of the function f of xy is equal to 3x plus y subject to constant x square plus y square is equal to 10. X square plus y square is equal to 10. Okay, solution. Given that f of xy what? 3x plus y. G of xy, x square plus y square is equal to 10. G of xy is equal to k now. Okay. So fx is equal to lambda gx. Implies that. So your fx is what? 3. So lambda into twice x. We call this as 1. We call this 2. So Fy lambda gy. So Fy is what? 1 lambda twice y. All this is true. Okay. Now, so from 1 implies lambda is equal to 3 upon twice x, and 2 implies lambda is equal to 1 upon twice y. So that means what? 3 upon twice x is 7, 1 upon twice y. So that means 6y is equal to, okay, so 2 get cancelled actually, 3y. This 2 get cancelled. 3y is equal to x. So you have the value of x is equal to 3y. Okay, so I have to write here x square plus y square is equal to 10. All call this as 3. Okay, so from 3 implies, I put the value of x is as 3y now. So x square, this is what? 9y square plus y square is equal to 10 now. So y square, 10y square is equal to 10 means y square is equal to 1. Y is equal to plus or minus 1. Okay, so now with the help of this 3y is equal to x, you get this value. So we get the value of y, and to find the value of y, value of x, we will apply this now, right? So if y is equal to 1, then x is equal to 3. If y is equal to minus 1, then x is equal to minus 3. So therefore what? 3 1 and minus 3 1 are minus 3 minus 1 are critical points. Okay, so now we'll find the value of f of xy at both the points. Okay, so f of 3 1 is what? 9 plus 1 is 10 now, and f of minus 3 minus 1 is minus 10. So max f is equal to 10 and minimum f is equal to minus 10. So the problem is over now. Right? So very simple. So but only what? You have to find the values of x and y. That is the crucial part. And how to solve that equations 1, 2 and 3. There is no hard and fast rule. Okay? So you can use any method which is suitable for you. So we take the next problem. Use Langrages multiplier to find maximum minimum value of the function. So this is what? Y square minus x square. Y square minus x square. Subject to the condition. The condition is very important here. So 1 by 4 x square plus y square is equal to 1. Okay, so solution. Given that f of xy is equal to y square minus x square. G of xy is equal to 1 by 4 x square plus y square is equal to 1. Okay, so fx is equal to lambda gx. Implies that. So your fx is minus twice. Okay, I will check the equation is correct or not. Yes, y square minus x square. Equation is correct. Okay, now minus twice x. So lambda into what? 1/2 x now here. 1/2 into x. So I will call this as 1. So now fy is equal to lambda gy. This implies that fy is what? Twice y. Lambda into twice y. I call this as 2 now. Okay. So what? From 1 your equation is what? 1 by 4 x square plus y square is equal to 1. This is third one. Okay. So from 1 implies that. So what you have to multiply by 2 here. So what happens then? 2 here. This is minus 4x. Minus 4x is equal to lambda x. So this implies that lambda is equal to This implies, so see, if you take a, so this implies that, okay, I will shift the 4x to that side. So what happened then? I can take x common. So this is lambda plus 4 is equal to 0, right? And this implies that x is equal to 0 or lambda is equal to minus 4. Lambda is equal to minus 4. Okay. So what I will do, I will put x is equal to 0 in 3. So x is equal to 0. This implies that, so this implies that x is equal to 0. This implies that y square is equal to 1. That means y is equal to this plus or minus 1. Okay. Now I put lambda is equal to minus 4. Okay. So if lambda is equal to minus 4, then I put that in 2 now. Then 2 implies. So put the lambda is equal to minus 4 here. Your 2 to get cancelled. Right? So lambda is equal to minus 4. So see this is what? Y. This is y now. Okay. 2 to get cancelled. Lambda is equal to minus 4 y. Right? So this implies that 5y is equal to 0. That means this implies that y is equal to 0. Okay? I put y is equal to 0 in 3. So 3 implies that 1 by 4 x square is equal to 1 now. Right? So x square is equal to 4. So x is equal to plus or minus 2. That means if y is equal to 0, then x is equal to plus or minus 1. And if x is equal to 0, then y is equal to plus or minus 1. So see how many points we get. So if x is equal to 0, then y is equal to plus or minus 1. And if y is equal to 0 and y is equal to 0, so what do we get? X, y is equal to 0, x is plus or minus 1. Plus or minus 2. Okay. Now both here x square and y square. So plus or minus we can so we'll find the value of directly at 0 plus or minus 1 plus 2. Because what, this is y square, this is x square. So square of the minus 2 is also 4 and square of plus is also 4. So these are actually 4 points. Okay. So I will not separate that because my function is what? Y square minus x square. Power of all x and y are even. Right? If there is the power of x is odd, then you have to separate this. Right? But here what? So we'll take the benefit of the even power of x and y. Okay. So if there is the odd power of x and y, then we have to separate all the 4 points and we have to find a value at value of the function at all the 4 points here. But here what? There is a x square and there is y square. So I will take the plus or minus as it is. So I will find directly the value of at the point plus or minus 1. Actually these are the 2 points. So this is what? Then x square, y square is what? 1 then, right? And minus 0. So this is 1. This is 1. Now then what? Plus or minus 2, 0. So this is what? Then 0 minus 4 now. So this is minus 4. So which one is maximum? 1 is the maximum and minus 4 is minimum. So this is what? Maximum value of f is 1 and minimum value of f is what? Minus 4. Is minus 4. And you want what? To find the maximum and minimum value of the function. Right? So maximum value is 1 and minimum value is 4. Okay? So we are good. We take the next problem. We take use Langrages multipliers to find the maximum and minimum value of the function. We change the function only and subject to the condition find maximum and minimum value of the function f of x y z. So this is what? X y z. X y z is equal to x square y square z square. Okay, subject to the condition x square plus y square plus z square is equal to 1. Is equal to 1. Okay, solution. Given that f of x y z is equal to x square y square z square. G of x y z is equal to k. That is what? X square plus y square plus z square is equal to 1. Okay. So now fx is equal to lambda gx. Imply that. So your fx is what? Twice x y square z square lambda into twice x. lambda into twice x. Okay. So now Fy is equal to lambda gy implies that twice x square y z square lambda twice y. Fz is equal to lambda gz implies that so twice x square y square z lambda twice z lambda twice z. And the condition is what? X square plus y square plus z square is equal to 1. I call this as 1. I call this as 2. I call this as 3. I call this as 4. Now with the help of these 4 equations, you have to find the values of x, y, z and lambda. So what we do? So now see, 1 implies so your 2 get cancelled, right? Your x is there, so either x is equal to 0. If x not is 0, you can cancel this, right? So that means what here? Lambda is equal to y square z square or x is equal to 0, right? Lambda is equal to y square z square or x is equal to 0. What 2 implies? 2 implies. Or 2 implies your 2 get cancelled. You can cancel y if y not equal to 0. That means what? Y is equal to 0 is there. Or so if y not equal to 0, then you can cancel this y. Then what? Lambda is equal to, you can cancel y, then lambda is equal to x square z square. X square z square or y is equal to 0. And third implies that lambda is equal to what? X square y square or z is equal to 0. Right? So therefore x is equal to 0, y is equal to 0, z is equal to 0. Okay? Or so this is what, and x square y square is equal to x square z square is equal to x square is equal to y square z square. Okay? So that means what, this implies that x square is same as y square is same as z square, right? X square is same as y square is same as z square. So if x square is same as y square is same as z square, that means what? 3x square. That means what? This is 4 implies that 3x square is equal to 1. Because what? If you put y in x square y square z square, I write y square as x square, z square as x square plus x square plus x square, that is 3x square. So this implies that x is equal to plus or minus 1 by root 3. Plus or minus 1 by root 3. So therefore what? Y is also plus or minus y is also, so this law or so y is also plus or minus 1 by root 3. So that means what here? So x is equal to plus or minus 1 by root 3. Y is equal to plus or minus 1 by root 3. Z is also plus or minus 1 by root 3. Now see your function what? X square y square z square. So directly we will find the value of the function. Okay. Now note that if, see, this is the product of x, y, z. That means if your x is 0, then function is 0. If your y is 0, then function is 0. Z is 0, then function is 0. Right? So if x is equal to 0, or y is equal to 0, or z is equal to 0, then f of x, y, z is equal to 0. Right? So therefore what? So because this product, so no need to find if x is equal to 0, no need to find the value of y and z. If y is equal to 0, then no need to find the value of x and z. If z is equal to 0, no need to find, because what? If one of them is 0, then so function will be 0, right? So we want to find maximum and minimum value of the function, right? So we want only the maximum value and minimum value of the function. We don't want to find actually. So Now so I write it because of their x square, y square, z square. So I will take plus or minus now. Plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. Is what then? 1 by 3, 1 by 3, 1 by 3 is equal to 1 upon 27. So maximum value is what? Maximum is what? 1 upon 27. And minimum is what? Minimum value is 0. So maximum value is 1 by 27 and minimum value is 0. Okay. So the problem is over now here. Okay. So this is very simple problem actually. So only this part is important. Which part? So how to find the value of this x, y, z? How to solve the equation 1, 2, 3 and 4? This is only the important thing here, right? And that part is the crucial part, right? So once you solve this one, then no problem for this one. Here we are not applying the second derivative test here. Okay. So I hope that you understand all the things. We'll stop here.